Okay, so next lesson will be about graphing rational function. So this is the consolidation of all what we have learned in chapter 2, rational functions. Okay, so we will be having steps on how to graph a rational function. So first is to simplify the function. Make sure to transform it on its simplest form. Next is to find the vertical asymptotes. Next, you need to find the horizontal asymptotes, or if horizontal asymptote is not applicable, you need to find its oblique asymptote. Then plot the points from left to the right of the vertical asymptote, or if you have more than one vertical asymptote, it is important to plot the points between and beyond the vertical asymptotes. So let's have an example. So negative 3 over x plus 2 minus 1. So I would like to transform it in its simplest form. So which will be y is equal to negative 3 over x plus 2 minus x plus 2 over x plus 2. So this will be negative 3 minus 2 will be negative 5. So negative x minus 5 over x plus 2. So this is the simplest form of our rational function. Now, we need to draw the asymptote. So first, we need to identify the vertical asymptote. So vertical asymptote will be related on the denominator. This will be x plus 2 is equal to 0. X is equal to negative 2. So vertical asymptote will lie at negative 2. And the horizontal asymptote. So horizontal asymptote will be the comparison of the degree of the numerator and the denominator. So the degree in the numerator is 1. Denominator is also 1. Turns out they have the same or equal values. So we need to divide the numerical coefficients of the respective highest degree variable. So this will be negative 1 over 1. So the horizontal asymptote will lie at negative 1. Okay, so would like to draw this one. So I'll be using blue for the vertical asymptote at negative 2 here. Okay, and at y is equal to negative 1 around here. Okay, so let's plot the points from left and right. So let's have the values of domains at the left side, negative 3, negative 4, and negative 5 here. So we just need to substitute it with our simplest form of the rational function. So this will be x minus 5, x plus 2. So let's have negative 3, negative 4, and negative 5. So substituting these values will give you 2, 1/2, and 0 respectively. So negative 3 and 2, this will be here. And negative 4 and 1/2, this will be around here. And negative 5 and 0, this will be around here. So if you draw a curve, so it is important to consider that the asymptote will be the boundary line. So our curve will approach this asymptote only, but it will never intersect. So this is the left part of our graph, left of the vertical asymptote. So right part will be these values, negative 1, 0, 1, and 2, and 3, and so on. So substituting the values of x will give you these values of y. So negative 1 and negative 4, this will be here. 0 and negative 5 over 2, so maybe around here. 1 and negative 2, around here. And 2 and negative 7 over 4, around here. So this will be our curve. So this will be our graph of this rational function. So again, make sure to not intersect these asymptotes. So they will serve as the boundary line. Our curve will approach those boundary line, but they will never intersect. Let's have another example. 2x squared over x squared minus 9. So again, we need to simplify this function. And it turns out it is already in its simplest form. So draw the asymptotes. So first identify our asymptote. Vertical asymptote, get the denominator. So this will be x squared minus 9 is equal to 0. So this will be x squared is equal to 9. X is equal to positive negative 3. Okay? So next one is the horizontal asymptote. Comparing the two, they have equal degrees. So this will be, the degree is 2. The degree is 2 also. So we need to divide their numerical coefficient, and it will be, horizontal asymptote will be equal to 2 divided by 1, which is equal to 2. So I would like to draw 2 here, and a vertical asymptote at 3. So I'll be using color red, green, at negative 3, and also another vertical asymptote at positive 3. So let us label this one vertical asymptote 1, vertical asymptote 2. So horizontal asymptote lies at the positive 2, around here. Okay? So using our simplest function expression, so we would like to substitute all the values from different regions. So those on the beyond, from left and right, and from the middle or between these vertical asymptotes. So let's start with between. So this will be negative 2, negative 1, 0, 1, 2 between the two vertical asymptote. So substituting those values of x will give you these values of y. So we would like to plot these points. Negative 2 over and negative 8 over 5. So maybe around here. Okay. I'll be using other color. Negative 1 and negative 1/4 may be around here. 0 and 0 here. 1 and negative 1/4 around here. And 2 and negative 8 over 5 around here. So draw the curve. And again, the asymptotes near them will serve as the boundary line. So they will never cross this boundary line. So they will just approach, but they will never cross this asymptote. So it is asymptotic to the vertical asymptote 1 and 2. So let's try the left side. So from negative 4, negative 5, negative 6, and negative 7, just substitute the values of x. So we will be having negative 4 and 32 over 7, or 4.5. So this will be here. Negative 5 will be having y at 25 over 8, or 3.1 around here. So negative 6 and 8 over 3, or 2.7. So maybe around here. And negative 7 will be 49 over 20, or 2.45. So it will never cross this this horizontal asymptote. So it turns out that our curve is asymptotic to the horizontal asymptote and the vertical asymptote 1. So they will never again intersect this asymptote. And from the right side, so again, substitute the values of x, 4, 5, 6, and 7. You will get this set of values, 32 over 7, 25 over 8, 8 over 3, and 49 over 20 respectively. So let's plot the points. So this will be our curve. They will just approach these asymptotes. Okay? So that is how we graph rational functions.